Please welcome Developer Advocate from Google, Marks.
Thank you. Today we're going to talk about mobile mapping. So mapping and mobile devices go hand in hand together. These are inherently location-based devices. Now, most of you are thinking I'm going to talk mostly about Android, and that's probably correct. But I'm also talking about iPhones, iPads, and any other devices that develop some WebKit browsers. These devices, they come with a variety of sensors on them. Think about a few years ago, we didn't really have all these sensors. We didn't have compasses. We didn't have GPS devices. We weren't carrying around these incredibly powerful computers in our pockets. Well, today I'm going to talk to you about the different options you have for developing a map on one of these devices. And I'm going to talk to you about, more importantly, the optimizations that you can use to get over some of the limitations that the devices present. So I just want to give a quick overview. You'll see here, this is a list of the different APIs that Google provides for mapping. And not included on here are actually two important ones, the Android map view and the Apple map kit. And I didn't include those because they're not, strictly speaking, part of the Google Geo team, but they are important parts, and I'll talk about them later. But this just gives you a sense of all the different tools that you have at your disposal when you are working with the Google web-based APIs. Okay, so let's talk about the different options that you can use. And I've listed them here. Now there's three basic categories of them. There's a native API, so that's, as I mentioned before, the Android map view and the iPhone map kit. These are written in the code of the different SDKs, and they work only on those devices. There are web browser based, and that's using the JavaScript API or the static maps API. And then there's this hybrid approach, which you can use, which is creating a native application that loads one of the web-based viewers. I'm just going to go over the advantages of the different technologies right here. So you see here, this isn't all the features. These are the major features of the different APIs. And you'll see that in any one of them, you can add a map, you can add a marker, you can, in most of them, you can do basic geocoding, although not on the iPhone yet. You can add in polygons and polylines with the latest versions of all of those. But the JavaScript API provides you with a lot of additional features. You can do custom map tiles, styled maps, load KML and GeoRSS files. You can use directions. And you can do direct geocoding, which, as I mentioned, isn't available on the iPhone. And there's a whole host of other features that are not available to the native APIs that are part of the JavaScript API. So I'm going to focus on that as sort of the direction of which I think you should go. But I want to run over the different options that you have and just sort of generally talk about the other ones. So let's talk about the browser-based specifically, one of the general advantages and disadvantages of them. So as I mentioned before, this works on any full JavaScript browser, which means you can write a map that works for your desktop, your laptop, and an iPhone or Android device or any other WebKit browser or JavaScript-enabled browser. You can get access to some of the phone features that you might see on mobile devices through HTML5 and hopefully other interfaces that are coming out. Basically, it's a write once. As I mentioned, you can write for all these different platforms. You basically created your map once. You get rapid development. You can host it on your server. You can make changes quickly to it without having to interact with somebody's phone. On the downside, you don't have access to the App Store, the marketplace, where some people actually find their applications. So this is your basic sample code for this, and you can get this off of our documentation. But this is basically all it takes to get you started with a basic map. Okay, so the next thing I want to mention is the native APIs. Now, the advantages here, as I mentioned, is you get full integration with the SDK. Anything that you can do on the phone, anything you can access on the phone is available to you through that, including things like contacts and other things that might not be available through the WebKit browser. You get the App Store and Marketplace discoverability. That is, people will actually find your applications through these mechanisms. And you get, that allows you to sell the applications for money. On the downside is it's a little bit harder development, right? If you want to do something that works on Android and on iPhone, you have to write something in Java and something in an Objective-C. And they have no support outside the platform. That is, if you wanted to then also create a website, you would have to recreate your map entirely. So these are good options if you're just developing for one platform, but if you're developing for multiple, then you probably want to use a different approach. So then hybrid browsers, browser native. The advantage of this approach, as I mentioned before, is that you can create your map once and use it on any platform. But you can also integrate it with native functions in your native SDK. So you can integrate it with your Android and iPhone applications. Now, this is a bit more difficult than just writing a web-based application. You still have to write your Objective-C and your JavaScript for these different platforms. But at least as far as the map is concerned, you really only have to do it once. And this is an example. This is some of the basic code that you would need to get it working in Android. You basically create a web view, and then you can expose JavaScript interfaces within that web view that allow the JavaScript API to interact with native functions in your application. So one thing I wanted to do before I go into some of the other options, and I'm going to do some demos of some features that I think you really should use, is just to talk to you about one thing, which is user interface. This is one of the downsides of mobile applications. If you create a site for a desktop or laptop environment, pretty much everybody who is using those environments has a decent-sized screen. Now, they might be on a netbook, so they might have a little bit smaller screen, or they might have a giant 30-inch monitor or something like that. But consistently, you can see that they can read things. But as you can see here, your usability is going to be very different on different kinds of devices. So here we have an Android device. This is actually using navigation right there. This is an iPad. This is another Android device, and this is just a static map that could be used on anything. So this is something you need to take into account when you're doing this, doing your development. What does it look like, and how does the user interact with it? Now, part of the advantage of using the web-based browser-based Google Maps API is we can take care of some of that, right? You don't have to think about what happens when somebody double clicks on something or somebody does the pinch to zoom, because we figure out those problems for you. Whereas if you were creating this yourself or you were developing a native application, you have to think about what happens when people do different things on the different devices and how they interact differently. Okay, so now I want to get to a piece that I think is a little bit more useful, because I've talked a lot in the past about these different ways you can develop. But I want to talk to you about optimizations, things that you can do that will make your applications better. Now, the reason I wanted to talk to you about this is because there's some inherent limitations on these devices. And their inherent limitations include things like bandwidth. How much bandwidth do you have? How much access do you have to anything at any one time? And latency. How long does it take for something to actually load on your Android device, on your iPhone, on something like that? And that's based on network problems and bandwidth that we pretty much solved in the desktop environment, at least in the developed world. But we haven't solved on mobile devices. Actually, I come from California, where we have much worse mobile networks than you do here. So you all have solved some of these problems already, but still you need some optimization. And also because these things don't come with nice video cards and lots of CPU power, and they do take lots of battery to run. So you want to optimize as much as possible so that your users aren't burning their bandwidth, and they get a good experience. So these are just some of the things that I think that you can do. The first is to do Kml layers. Now, Kml is it's a file format. It's an open standard that was originally developed for Google Earth, and its purpose is to do a geographic presentation language. So it's basically to describe how something looks. Now, it was originally designed for Google Earth. We gave it away as an open standard, so anybody can write KML. Doesn't have to work in Google Earth or Google Maps or whatever. But Google Maps does support a basic subset of KML, and this allows you to load it very easily onto your map. So this is the basic code for it. You create a layer, and then which has a URL to a KML file, and you add it to your map. And then you can actually, now in version 3 of the API, you can actually get access to the DOM structure of that so that you can get access and turn on and off individual features, which is new in the version 3 of the API. Okay, so just a little bit more about this. If you want to use a KML file, it needs to be on a public website. You need to have it posted somewhere so that our servers can go out, find it. And what we do is we return back to the JavaScript map, we return back an optimized set of overlays. Basically, tiles if it's very large, or highly optimized JavaScript objects if it's a very small file. Why this is good for you is it doesn't burn as much bandwidth. It doesn't take as long to load. It's highly optimized, and you don't have to, again, go through for each of your objects creating a JavaScript object, which is probably a little bit more heavyweight than we would do, to display it on your map. So this helps you avoid that problem. Now, Fusion Tables is a new product. It's about a year old. We released it last summer, but it's recently got really, really good. Now, Fusion Tables is it's basically a way that you can upload tabular data to Google servers and then you can do custom visualizations for it. Now, I think at this point, it's probably best to actually do a little bit of demo, because I think probably not many of you have actually seen fusion tables before. So Fusion Tables is just google.com/Fusion Tables. There's a bunch of public tables, and then you can upload your own. At the moment, it's in beta, and it allows you to upload up to 100 megabyte files, basically spreadsheets. So it can be Excel, CSV, or Google Spreadsheets, or some other text format. And as you see, it has just basic tabular data. Now, it allows you to do something fun, which is once I've uploaded it, I can click on Visualize and get a map. And there I have a map. So this is one very quick way that you can get a map without actually doing any work. Now I can click on that and get some actual data. Now you may be wondering about the data that I chose. I chose Chicago homicides because people have the stereotype about the US and about Chicago that it's incredibly violent, and not entirely untrue. So I just wanted to use that particular data set for that. Yeah. Often when I was traveling in Eastern Europe, people would say, Chicago, that's where Al Capone was from. So maybe that was before y'all's time. Okay, so this is really great, and this seems like a really great feature. However, the Fusion Table maps are not directly optimized for use in version 3 of the API. And version 3, as you may know, is our API that's designed for working with mobile devices. So what we allow you to do is to add a layer directly in the API. So you just create a Fusion Tables layer, add it to your map, and you have that data processed directly onto your map. Now, as you may guess, it uses the same process as we do for Kml files for optimizing. So this allows you to do really fun stuff with your tabular data, build up a map very quickly, and then share it with your mobile users. Now, Fusion Tables also, by the way, this wasn't strictly supposed to be part of my presentation, but I'll add it in anyway. Fusion Tables also has its own API, which means if you want to interact with it programmatically, you can do that. You can create a form, allow your users to add data, and then build a mobile map based on their input. And if you'll notice in here, the layer allows you to do a query directly from within the table. So there's a SQL-like query language. It's just some basic SQL functions on the table, and you can incorporate those directly into the Maps API, so you're only querying a small subset of your data. One other trick, which I haven't shown here, is that you can put KML into the columns of your tabular data. So one of your columns could be polygons or points defined in KML, for instance, and that would then show up in the map as those polygons or points or lines or whatever the KML is that you're trying to show. And the idea there is that allows you to define geometries within a tabular format and then relate them to other tables within Fusion Tables. So if you haven't experienced Fusion Tables yet, you should really go ahead and take a close look at that. Okay. So I wanted to mention this. This is not strictly speaking an optimization, but I wanted to talk about how we optimize the Street View experience for your mobile experience or for your web-based experience. So the Street View in Google Maps API, and I'll show a demo of this later. In version 2 of the Google Maps API, I used Flash. Now, Flash, as I think probably anybody who's designed for mobile knows, is Flash doesn't really have a mobile experience. The iPhone explicitly forbids it. I haven't seen any decent Flash apps for Android yet. I'm not even sure if they have Flash yet on Android. I know Adobe's announced that it's going to. But anyway, we decided before even all that came about that we wanted to optimize for this mobile experience, and in order to do that, you can't use Flash. So we set it up so that the new Flash in the Maps API uses, it basically gracefully degrades. In a high-performance browser, and that is if you're talking about the developer builds of Chromium or Safari or Firefox or a variety of other high-end modern browsers, we're talking about the nightly builds that have WebGL enabled. It will use WebGL, and it'll detect. It'll see, is this a browser that supports WebGL? Okay, I will use WebGL. If it doesn't, it checks to see if it's a browser that supports HTML5 Canvas. And that's where the mobile browsers come in. They all support the Canvas tag. And so you get good performance with Canvas. And then if you're not in a modern browser, say you're using an older version of Internet Explorer, it'll use HTML4 and JavaScript to script that experience. And all that is to say that basically now you can have, as of May, you can have Street View in a JavaScript browser on your mobile device. One thing I'd also like to mention is that customized Street View panoramas are also now allowed. So if you wanted to put a Street View panorama and you had some imagery from a place where we don't, say inside a building, you can now do that. So that was one of the big asks. A lot of people asked for, can I put in a custom panorama? Yes, you can. Okay, so the next thing I wanted to mention is HTML5 geolocation. Now, as you know, Google right now is all about HTML5. We think that it's the wave of the future. It's going to really transform web applications. And one of the things that HTML5 gives you is geolocation. Well, geolocation is now supported in the latest versions of all the browsers on these devices, which means you have a common way of asking the browser, where are you? Now, this could be the browser on your desktop, your laptop. It can be the browser on your phone. Basically, the JavaScript doesn't know how you got the data. It just knows how to ask for the data. Generally, with a mobile device, it's some form of GPS, or maybe GPS that is combined with Wi-Fi detection. With desktop laptops, it's Wi-Fi and perhaps IP-based, depending on your particular browser. Now, only some modern browsers support this, so typically you'll want to detect whether it's there or not. And here's a basic example of using this. And I'll have a demo in a minute. And basically, all you have to do is, this is your basic navigator.geolocation.getCurrentPosition. So you see here, get current position, and then you give it a callback that does something. And here I just have, it doesn't actually say what it does. You can do, there's actually quite a bit more that you get with geolocation, and I'll show you an example in a minute. But here, for instance, you can get a success callback, which is, what do you do if you succeed? And then an error callback, what do you do if you don't? And you can also put in parameters like, what's the maximum age of this? So when you're carrying around your mobile device and it's unable to get a location for over a certain number of seconds, you could say, okay, you make sure that I'm only using the age if it's over a certain number of seconds, like within the last hour. Because it's not relevant to you if they've been there for 5 hours. Maybe they turned their device off, or maybe they're in the subway. I don't know what the reasons might be that it wouldn't be able to get the location. But this allows you to do one common way of detecting things like how old is this? Where were they at what point? Okay, so the next thing I wanted to mention here is styled maps. This is something we released back in May as well. So a whole bunch of stuff got released around Google I/O. Now, styled maps allow you to take control of how the map actually looks. So Google Maps have a very distinctive look. If you go to maps.google.com, you can see how it appears. Roads are certain colors depending on how big they are. The water's always the same color and all that. And for a long time, we got requests to change that. And people would do lots of things like add translucent overlays over their maps, or add transparent overlays, over the maps to try and change the colors to match their own website colors. And we decided we wanted to give people a lot more control over that. And the reason being that many people want to change the actual appearance of the map. For a long time, we kind of resisted that because we thought, well, we want all Google Maps to look the same. And then we realized that not all our customers wanted their Google Maps to look the same. So you can do a lot of interesting things here. You can change colors of a lot of different objects. You've got administrative units, and that means cities, states, provinces, countries, small localities. So all those things, you can give them a much big, you can change their colors, you can change the boundary, the width of the boundary lines. You could get rid of them, in fact. You could change the font size for the names of these different things, including getting rid of them entirely. So you could have a map that had nothing but the boundaries on it and nothing else. You could change the color of roads, and roads of different sizes. So major highways can be different colors than they are, or small roads or medium-sized roads. These can all be different. You have a very granular control over that. And as I mentioned, you can change the size and the color of the labels. So this gives you a lot, as I mentioned, a lot of control over your presentation. And the reason why it's important to do it this way, instead of some fashion that some hack that you might have done before, is we control the server side. We generate the tiles on the fly for you, which means that there's essentially no change to the tiles that are received by your users. So your bandwidth and your performance are not going to change based on this, based on you trying to do some hack to change the color of the tiles. So I want to actually take a look at this experience. So I believe that was, yeah. So this is a Google map right here. Now you'll see that the colors are pretty different. I actually removed all the roads, and I changed the color of the water to black. And you can't see this because it's actually off the screen. You'll see there's a different control here, one that says no roads, and that's the default, and this is the standard map. So you can see how that change there changes, it's pretty significant change. It's pretty easy to do this. And of course, I did not bring up the, well, I'll show you in a minute. There's actually a wizard that we use that allows you to select the different colors and sizes of fonts and things like that. So I'll show you the wizard. It's linked off of off of our documentation. But let me just show you what this looks like in code. So you'll see here in my basic function, I just define a set of styles. And this is kind of like CSS, right? Using CSS to define things, but we create our own way of doing it. And so here you define a feature type, and here I said road. And the element type, and that's all, so that's all roads. And then the visibility, I turn the visibility off. And I do the same thing with points of interest. So on maps, we have things like hospitals and restaurants and banks and landmarks and all that sort of thing. Turned all those things off. So those don't show up at all. It makes the map a cleaner experience. Now on a desktop, it's not as big a deal, but on a small device, cleaning up your experience, making a better user interface, making a cleaner user interface is really important. And here again, I have feature type water, the type of water, so ocean, lake, river, that sort of thing. And then I just changed the saturation, the lightness, and the gamma so they were really low. That turned it black. And then there's a little bit more. It's not that simple. There's a little bit more to it than that. Here, I create a series of map type control options, so I have different IDs on my maps for my map types. Basically, create a road map and a my map type, custom map type. I create the map. I give the style. I create this variable styled map options and create the name no roads. So that's the name you saw in the control. And then here I have and our map type for no roads map type is this new styled map type using the styles from up there and then these options. And then I set the map type, this map type ID to this kind of map type. So it's pretty easy to do that. And then you have a lot of, as I mentioned, a lot of control over the map. So I wanted to take a moment to look back. I talked about geolocation, and I wasn't sure how long the different things would take. It looks like I have a pretty good amount of time here. So what I'm gonna do now is just show you another demo. So this is Geo Locate. This is just you basically using geolocation. So this map is actually centered in Australia. I do that deliberately so that when I pull it up in initially, if it fails to find a location, it's going to go somewhere where I'm not likely to be at that moment, because they have other maps people to present in Australia. But you'll see it's centered here, and actually put a marker where it was centered. And I'm going to zoom in. I actually don't know this area very well. How close are we to? Is this at all close to where we are? No? Okay. Pretty far. Okay. Well, that's unfortunate. So the browser's giving it a bad location, which is something you have to deal with. But you'll see there's this little circle there, around there. And that's because the object that you create, the position object, gives you precision. It tells you how close it is in meters to that actual location. And so in this case, it thinks it's wrong, but it thinks that it's pretty close. And so what I did was I just drew a circle around it. And that's an important thing to remember too, how close the device thinks you are to an actual location. Now let's take a look and see what that looks like. Both of those look like on different devices. So here, you may have seen it was in Australia. And here we have the location. How close am I now? Does that look better? I don't know if we can get this to be a little bit lighter. But anyway. So what I'm going to do now is I'm going to zoom in here. And you'll see, yes, now I remember having looked at this before. So you see, it's fairly close, but it's not actually really 100% positive where it is. And that's because I'm indoors. I'm not going to get a very good GPS location. So what it's doing is it's looking at all the Wi-Fi networks nearby and trying to guess pretty much where I am. Oh, that's pretty dark there. Yeah. Okay. So let's switch back to the computer here. I wanted to show you the, can we switch back here to this computer? I wanted to show you the code from this. So you'll see my initialization code is actually pretty standard. This is just basic maps code, right? It creates it, centers it, and you'll see right there, that's in Australia. Then I create the new map, and then I have this function do geolocation. So do geolocation does this check. It checks to see if there is a navigator.geolocation object. If there isn't, this doesn't actually do something, but you could do something else. You could check and see if there was an IP location that's available or some other method. And here it says navigator geolocation, get current position, and if it succeeds, do one thing, and if there's an error, do something else. And the error, we're just going to go over the error. It's not really important. But here, you have, this is position success. Grabs a position, and then it checks. And what I did here was I used a few different methods. Because one of the things about HTML5 is, for the last couple of years, they've been figuring out exactly what the standard is, right? And so some older versions of browsers have different ways of actually getting them as the standards evolved. So here are the different things: position.coords, position.coordinate, and position. Those are the three major options that different browsers use. And then I just basically create, using that chords element, I just chords latitude, chords.longitude. I create a new lat long, and then I get from the accuracy chords.accuracy, set the center to the lat long position, set the zoom level, and create a new marker. And then I create a new circle with, here I had the fill opacity of 0.33, and the radius of inaccuracy there. So a circle is it's a new geometry in the Google Maps API version 3, only available in that JavaScript API. And that's it. That's basically it. This is just some other stuff for the page. So you can see geolocation's pretty easy. Now I just wanted to take a moment to take a look at the styled map in this, on this device. By the way, I'm demonstrating on a Samsung Galaxy. It's one of the new sort of tablet-like devices. But here you can see, and this actually looks better on the actual device rather than the overhead. But you can see that it has all the basics of the map, and I think it looks pretty good. And you can see it's pretty clean here. Now, if I were to switch to the map version, it's a little bit busy. So this, as I mentioned before, cleaning up the user interface and finding a better way to actually to look at things. This is harder to interact with. But if you can clean it up so that you can have the experience that you want, and maybe it matches the color patterns of your web pages, then it's going to be a nicer experience for your user and for you. And it allows you to do a lot more that is creative without doing anything to sacrifice performance on your system. Okay, so I believe I've come to the end of my slides. I have. So what I'm going to do now, I've got, I think, 4 minutes. I'm going to give you another couple of looks at Google Fusion tables, just since I'm here. Actually, I did say I would try and find the styling wizard. So here we go. Sorry for this quick jump through these different documentation pages. So we provide this wizard for you, linked off the documentation, that allows you to both get the code that you need and play with it pretty directly in the API. So let's take a look at changing the water because it's got the most visibility here, the most change here. Now what I did there was I just turned off the water. Do you see how quickly that changed there, the map tiles? That's how performant it is. No real changes at all to your performance. Here I changed it green. Here I'm going to change it more of a purple hue. I'm slightly colorblind, so this may actually be more red than I was actually intending. And then let's take a look here. I'm going to go into Tokyo, because they tell you when you do demos, you should always relate it to where people actually are. And I'm going to change the landscape here. So let's say the natural landscape. I'm going to change that hue to. Actually, let me show you the points of interest here. So let's turn off all points of interest here. So you see how that cleans up things very quickly. Let's also add another style. Now look at administrative units and turn off localities. And turn off neighborhoods. So there's generally going to be a lot more boundaries in there. Anyway, so then what you do once you've set your the styles that you want is you click on Show the JSON, and it shows you the JSON that you would use in your application. Okay, I just got the 1-minute warning. So that is all. Thank you very much for coming, and I look forward to seeing all the new mobile maps that you've developed. So, thank you.